So in this lesson, I'm going to go over two more types of measuring concentration quantitatively. So we looked at mass percent for concentration in the last lesson. Now let's look at volume percent. So volume percent is just like mass percent, except now we're going to be using volume. So you're going to put the volume of your solute on top, and that's going to be whichever substance has a smaller volume. That's what you're actually dissolving into the solvents. So it's volume percent is volume of the solute divided by the volume of your solution. And then you're going to multiply by 100%. Okay, so let's actually do a practice problem. This says, what is the percent by volume of ethanol in a solution that contains 35 mils of ethanol? That is my solute, so I'm going to put 35 mils on top. And 115 mils of water. Well, water is my solvent, so I'm going to take my solute, volume 35, and add that to my solvent volume, which is 115, and so that gives me 150 milliliters. I'm going to multiply this by 100, and I can get my answer. So the answer that I get when I actually divide is 23.33%. I've got 2 sig figs here, 2 sig figs here, so I'm going to just round this to 23%. Okay, so that's volume percent concentration. The next type of concentration, which is one we're going to be using pretty extensively in this class, and we use a lot in AP chemistry, is molarity. So molarity is instead of volume or mass, it's the moles of your solute divided by liters of your solution. Okay? The units for molarity are capital M, okay? And that's pronounced molar. So if I have a 10 molar solution, that's describing the molarity. Okay, so for this problem, it says calculate the molarity of a solution that has 0.127 moles of sucrose in 655 mils of solution. Okay, so here I already have my moles of solute. In a lot of problems you'll be asked, calculate the molarity of a solution that has a certain number of grams of solute. So in that case, you would have to convert from grams into moles, but here I'm already in moles, which is awesome. So my molarity equals my moles, 0.127 moles, divided by, well, I need to be in liters of solution. So I'm going to take the 655 milliliters, and I'm going to convert that into liters. If you can do that in your head, awesome. If you can't, that's fine. But get used to needing to do that conversion because it's going to happen a lot. So they're 10 to the negative third liters in 1 milliliter. Okay, so I'm going to just end up dividing by 1,000 because that's what multiplying by 10 to the negative third is. So what I get for my volume is 0.655 liters. Okay, so that's what's going to go on bottom. That's my volume of my solution. Okay, and so what I get for my molarity when I do this, 0.127 divided by 0.655, I get, well, I want 3 sig figs here. I've got 3 sig figs here. So I got 0.19389. So I want to keep the 1, the 9, and the 3 is going to round up to a 4. So 0.194. And my units are molar, capital M. Make sure it's a capital M and it's molar. And that's it. Those are your molarity concentration calculations in your volume percent calculations.